Welcome to the PSoC Hackers Lab. In this session, let us create a precision full wave rectifier using the analog resources in PSoC 1. This block diagram shows how the rectifier is implemented. The input signal is AC coupled into a unity gain buffer using C1R1 through port 01. The output of the buffer is connected to the input of a modulator with a gain of 1 implemented using a switched capacitor block. The gain of the modulator can be switched between positive and negative using a digital signal on the modulation input. The output of the buffer also feeds a zero crossing detector implemented using a comparator. This zero crossing detector output is connected to the modulation input of the modulator. When the input signal is positive, the output of the zero crossing detector is high, resulting in a positive gain in the modulator. This results in the positive half of the input signal passed as it is. When the input signal is negative, the output of the zero crossing detector is low, resulting in a negative gain in the modulator. When the negative half of the input signal is passed through a negative gain, the output is again a positive signal. Thus, the output of the modulator is a full wave rectified signal. The output of the zero crossing detector is also brought out on P14. This output is just for debugging and is not required in the actual implementation. The same analog block that implements the zero crossing detector is also used to bring out the analog ground on port 05, which is used to AC couple the input signal. Let's now create the project. Open PSoC Designer and create a new project. Give a name for the project. Click OK. Select the CY8C29466 24PXI device. Select C for the main file and click OK. Now let us select the peripherals required for the project. From the amplifiers section, double-click on the PGA and then double-click on the comparator. This opens the comparator configuration window where select the Comp Z option, which configures the comparator as a zero crossing detector. Click OK. From the generic section, select the SC block, and from the miscellaneous digital section, select the digital buffer. Let us now configure the peripherals. Select the PGA. Rename this PGA _1 to buffer. Set the gain to 1. Select the input as analog column input mux 0. Select the reference as A ground and disable the analog bus. Next, select the comparator. Rename this to comparator. Select the input from ACB00 and leave the other parameters at their default value. Next, let us configure the SC block. Give a name, modulator. Set F cap to 16, clock phase to norm, A sign to negative. The gain of the modulator is set by performing an XOR between the A sign parameter and the output from the comparator. So we set negative here. Select A cap to 16. AC mux to ACB00. This is the input to the modulator. Enable the analog bus to analog out bus 0. The comp bus is disabled. Enable auto 0. CCAP is 0. Set ARF mux to A ground. FSW1 and FSW0 are on. We are not going to use the BMUX, so leave it unconfigured. Set the power to high. Next, enable the analog buffers on column 0 and column 1. Port 03 is to bring out the full wave rectified signal, and port 05 is for analog ground. Let us now configure the digital buffer. Rename to dig buff. Select comparator bus 1 as input 1. Input 2 is disabled. Input 2 clock sync is not used. Output 1 is connected to row 0, output 0, and output 2 is none. Now, click on the LUT on the row 0, output 0 and select global out odd 4, and then click on the global out odd 4 line and select port 14 and click OK. Now you can see the output is connected now to port 14. Let us now configure the global resources. Set VC1 divider to 6. VC1 is the analog clock to the modulator, and we are setting it to 4 MHz. Set the analog power to SC on ref high. All the other global resources are left at their default values. Click on the Generate Configuration Files button to generate all the configuration files required for the project. Let us write the application code. Open main.c. As this application does not require any interrupts, leave this line commented. Start the buffer at high power. Start the modulator in the SC block at high power. Start the zero crossing detector at high power. Start the digital buffer. Write to ACB01 CR2 register to bring out the analog ground on port 05. Write to the AMD CR0 register to select the comparator bus 1 as the modulation signal for the modulator. Once all the hardware is enabled, there is nothing else to do with the code. Let us now build the program. Once the project is built, the next step is to program the PSoC. Before we program the PSoC, let us have a look at the hardware setup. We are going to use the CY3210 PSoC1 evaluation board to test the project. The input signal from a signal generator is connected to one end of C1 with respect to VSS. The other end of C1 is connected to port 01. R1 is connected between port 01 and the analog ground on port 05. The full wave rectified output is available on port 03 and the zero crossing detector output is available on port 14. I have connected probes to the input signal, the full wave rectified output and the zero crossing detector output to observe them on the oscilloscope. The programmer is connected to the 5-pin ISSP connector on the board. Let us now program the PSoC. Once the device is programmed, click on the toggle power button to power the board using the programmer. Let us watch the output on the oscilloscope. The yellow trace is the input signal. The pink trace is the zero crossing detector output. Observe the zero crossing detector output is high when the input signal is positive and low when the input signal is negative. The blue trace is the full wave rectified output.